What?
Wait, are you? Oh no, my toy box.
Yeah, you're gonna need a new toy box.
Oh, that's a disaster. What's? Ah.
Oh, but this is kind of convenient.
Oh, it is because we're doing momentum.
Yeah, so we can explain, and what we can do is we can work out the speed that I hit that toy box.
Of course, more importantly,
do I need
a
an
new
ambulance?
Toy box? Yeah, new toy box. Absolutely.
Yeah, that's...
Yeah, so the ambulance is probably the winner there.
Alright,
anyway.
So, momentum. We did it in the very beginning of the A2 physics course.
Yes, we're going to be doing it a lot. The thing to know about momentum is it is always conserved. And you remember that it's P equals mass times velocity.
Yep, and it's always conserved, as Triv said.
Yeah, so the momentum before a collision, like we just had, will always equal momentum after the collision. That's quite important.
So we can work out the speed at which I hit that toy box.
We can. But first we need to know what our momentums were to start with.
Yeah. So here's me.
Oh, that looks just like you, Wayne.
Here's you.
Oh, yes. Yeah, okay.
Yeah.
Alright.
So firstly, we need the velocity that we came in together and the mass that we each had.
Yes.
So we can work out the initial momentum.
Okay. So I reckon that's like 2 meters and happened in a second.
Yeah, so let's just call it 2 meters per second.
All right.
I mean, this is all not that accurate, but it's not far off. So you were going at 2 meters per second. How much do you weigh?
I weigh, I'm not sure I'm comfortable with this. No, 60 kilograms.
60 kilograms.
Yeah.
That's quite light. Well done you.
Thank you. I have been watching the calories. So you're going the same speed, Wayne? Or?
Yeah, I'll say I was going at the same speed.
Yeah.
And I 90 kilograms.
Need to cut out those Toblerones, Wayne.
I do love Toblerone.
They're good now.
So we can work out the momentum of me as I was flying in and the momentum of James as he was flying in.
Yeah, so we have Wayne, so do that first.
70 times 2, mass times velocity, is just 140 as my momentum.
Yes.
Yours
So
is 60
me.
times 2, which is 120. Okay, so that's before, that's as we were coming in, before we collided.
Yeah. Now, as that has happened before, the end will have the same momentum, but it will have the same total momentum as if they had these two together.
Yes. So this all together, the momentum of the entire collision with me and James,
is 260.
260. Now we can actually, now we have to think about what it means for it to be conserved.
Yeah.
Afterwards, Triv stayed still. He jumped in, I went flying. So
Yeah.
his speed was 0 meters per second.
Which means our momentum must be 0. It must have all been transferred to Wayne. That's just called an elastic collision, but we'll get onto that a bit later.
We'll get onto that a bit more later, but what you need to know is because as we collided, his velocity was 0, his momentum was 0, so I must have had all of this momentum.
Yeah. So if Wayne's momentum is 260, we already know his mass. The only thing we don't know is how fast he was going. So we can then just rearrange it.
70
times our v. So we just divide both sides by 70. 260 over 70 isn't 3 and a bit. Yeah.
So let's say it was 3 and 5/7 meters per second.
Okay.
I don't know what 5/7 is, but you know, 260 divided by 70 would have given my velocity, and I think it's 100% for your A2 exam. Call an ambulance.
Definitely gonna need a new toy box.